Hai, Assalamualaikum. My name is Atiqah Sarif.
I, Fatnun Hidayah binti Jamiron.
My name is Sabrina binti Rahman, and we will be presenting our final year project entitled Recycling Bins Location by using Maximal Expected Coverage Location Problem in Johor Bahru. It is under supervision Dr. Zati Aqmar binti Zaharudin.
There are 12 parts that were included in this presentation outline. Introduction. Municipal solid waste is generated by household, commercial activities and other sources. This waste could cause odor pollution, a dirty environment or an increase in carbon emission that would extremely impact climate change. Hence, the waste needs to be properly managed, including the use of waste as a productive resources, such as recycling. Recycling is a part of a waste reduction program that involves waste collection, sorting, cleaning, and processing, which mainly focus on handling and converting waste in other products. Recycling facilities such as drop-off center or bins are important to increase recycling rates. Most importantly, these facilities are sufficient and accessible for all users.
Segment. First, awareness on waste reduction by recycling and reuse is still low among Malaysians. Second, lack of recycling bins in urban areas. Third, most of past study focus on general location problem. The objective of our project are to determine the recycling bins location in the selected study area by using MESCLP. Second, to determine the number of recycling bins allocated at each selected location by using MESCLP. Third, to analyze the recycling bins location by variation of MESLP parameters. Significance of our project are: first, allocate more recycling bins to make people aware of the importance of recycling. Second, increase the recycling rates. Third, reduce environmental pollution. The benefits are: first, cleaner cities are favored by many travelers. Second, optimal recycling bins location. Location will indirectly promote Malaysia tourism sector.
Scope of the study. This study is implemented by focusing on urban areas only, namely the city of Johor Bahru. Hutan Bandar MBIP was chosen because of its strategic location and it is able to attract the attention of facilitate the residents of the area, as well as the visitors to recycle their items. Potential recycling bins location are shopping malls, parks, residential areas, clinic areas, and school areas. These locations were chosen because spacious, capacity, and accessible at any time. Limitation of study. Despite the true preparation of this data collection method, there were limitations and flaws due to limited time and hard to collect data because of movement control order. The study has limited data collection since the implementation of MCO. It supposedly find the population for data demand, but this study used the NASA SIDAC population estimator.
Background theory. The study determined the optimal location of the recycling bins using MESCLP. MESCLP is used to find where the recycling bin should be located, obtain optimal travel time networks between demand and supply, and identify the best place to place recycling bins. Last, compare the time travel between nodes to find the best place for recycling bins to be located. Facility location models is divided into two parts. First, waste management system. Second, recycling bins location allocation. In waste management system, algorithm is used to determine the most cost-effective location for transport stations. Next, new multi-criteria mixed integer linear programming model is introduced for solving the municipal solid waste management location. Next, recycling bins location, which is allocation. Mixed integer linear programming models with geography information system is used to solve the bins location, which is allocation problem for household and recyclable waste separately. Next, variable models are used to provide the best site planning design for recycling bins urban solid waste while staying within the financial budget set.
Methodology. Research flow. It consists of three phases, which is collection of data, identify problem parameters using MESCLP method, and lastly, implement appropriate approach by using the Simplex Optimizer in Simplex Studio. The first step is to do in this study is to collect the data. This figure presents the node area with demand for the recycling bins. Therefore, the node I that represent demand location and the node J for recycling bin location. The next figure shows the network between one node J to the others. We use travel time between two nodes to represent the distance between demand and recycling bins location. The travel time was gathered by using Google Maps. The data for the travel time are shown as follows. Then the data on population density is collected by using the NASA SEDAC Population Estimation Service. The area is in the value of acres. Therefore, the data of demand of the node I can be shown as follows. Phase 2. Recycling bins location using MEXCLP. To locate the recycling bins, we use the MEXCLP model. The model formulation is as follows. Parameter QK is modified to QJK to indicate the different busyness level of having K bins at J location. Thus, the objective function 1 from MEXCLP is modified to 4. Constraint 2 and 3 are adopted from MEXCLP to ensure selected facility location J is able to cover all demand at location I. Constrain the facility J at most n facility location. Constraint 5 is introduced to ensure only at the covered demand location I is located with K bins. Constraint 6 limits the total number of recycling bins located at each area J to ensure there is recycling bins located each selected. Phase 3. Implementation using Cplex Solver. In this project, Cplex Studio will be used to find the best location to place the recycling bins. The figure shows the Cplex code that we use to get the result. Before implementing the required data into the Cplex, some of the collected data need to be further enumerated. Data of the demand, busyness level of having K bins at J location, Xj and Yik. From the MEXCLP, there are several parameters that can be various, which is T, K, N, and W.
The figure shows that within 3 minutes travel time, 100% demands are covered by having 3 recycle bins locations, which are at J3, J4, and J5, and only 1 bin are needed for each location. While second figure shows that within 5 minutes travel time, 100 demands are covered by only 1 location and 1 bin are located at that place. But for travel time 10 minutes, the result shows that we need more bins to cover the area of study, which that is contrary to our objective to find the optimal number of bins. So, by comparing the two results, we can see G3 can cover expected demand in around 314 users more than D5. But also, back to the objective, we select to cover study area by 1 recycle bin at 1 location. Hence, D5 shows the best result. From D3 shaded map, yellow region represents J3 that covers section I3, green region represents J4 that covers section I4 and I5, lastly blue region represents J5 that covers I1, I2 and I5. While from D5 map, there is only one color represents J5 that covers all section I1 to I5. MEXCLP was used to determine the recycling bin location allocation in Hutan Bandar Johor Bahru. As a result, all objectives are achieved. First objective achieved as we can determine the optimal recycling bin location, which is at J5. While second objective achieved as we get determine only 1 bin are allocated at selected location. This means by having 1 bin located at J5, the accessibility and availability are guaranteed. And third objective achieved through the variation of the travel times that provides alternative to the authority to make the decision. We recommend the problem is solved by using fuzzy maximal covering location problem in the future. This is because in real world, uncertainty exists make many parameters are difficult to identify. Examples of uncertainty are estimates of customer demands and travel time. An expert will usually estimate something based on his or her appetite. For example, demand budget is estimated as about 50 units per 100 meter.
Reference. That's all. Thank you.